Hello everyone, good evening. Welcome back to Gate Wallah English YouTube channel. I hope everyone is doing great. So till last class we have covered almost all the topics of precipitation, and in today's class we are going to finish this chapter. Okay, so everyone, before starting the lecture, let me tell you, you tell me first that am I fully audible and visible to you all, then I will begin. Okay, good evening Sushil and everyone. All those who have joined, kindly share the session, then we'll start it. Okay, so till now we have covered many topics. I hope you remember it. Okay, so till now we have covered all the topics of precipitation. The very first topic which we have discussed, let's have a quick recap within 5 minutes, then we'll proceed further. Okay, so we have discussed about water cycle, then we have discussed about global water distribution. Okay, global water distribution, like what is the volume of water which is present in different kind of phases. We have discussed it. Okay, like 70% water is in frozen form, 30% water is in liquid form, fresh water I am talking of. Okay, so how your water is distributed globally, that also we have discussed beautifully. I hope you remember it. Yes or no? Perfect. After global water distribution, we discussed water cycle. After water cycle, I went on to discuss catchment area, like what catchment area is, the concept behind it. Okay, what is watershed, what is basin, what is sink, all these things we have discussed very beautifully. Catchment area. Then after catchment area, we discussed residence time concept. Okay, I hope you remember that. After this, we went on to discuss water budget equation. Very, very important. Many questions have been framed in past year papers regarding this equation, and the basic equation is PRGET equal delta S. This is the main equation, and assumption basis, and on assumption basis we have simplified it and we have reduced it down to P minus losses equal to runoff. Okay, so this was our main equation. After water budget, sir, we started the next chapter, precipitation, in which the very first topic which we discussed was causes of precipitation. After this, we went on to discuss types of precipitation, all the different types of precipitation we have discussed. After this types of precipitation, we went on to discuss forms of precipitation. Okay, I hope you remember all the forms of precipitation. Rainfall was there, snow was there, sleet was there, okay, glaze was there, drizzle was there, hailstorm, everything. I hope you remember. Okay, good evening, Sushil, Souvik, and Ajay. I hope you have revised it. Tell me who all have revised it or not. Tell me. Kindly comment, everyone. Yes. So forms of precipitation, I hope you remember. After this, we went on to discuss measurement of precipitation. In measurement, I told you about two kind of rain gauges. The first was recording, second was non-recording. In non-recording, Simon rain gauge was there. Yes or no? I hope you remember. And in in recording, sorry, tipping bucket was there, weighing bucket was there, and your last one was natural siphon. Okay, natural siphon was the standard recording rain gauge of India. I hope you remember it. Yes or no? Good evening. Good evening. Perfect. So measurement is also very clear too, and which kind of instrument is giving you what kind of graph, that you should also remember. Okay, so after measurement of precipitation, we went on to discuss after measurement we went on to preparation of data. Okay, it should be continuous and consistent. So then we discuss estimation of missing data. In this estimation of missing data, sir, we discussed two methods. The very first one was arithmetic mean, the second one was normal ratio. Okay, I hope you remember both of the formulas, important. They can be asked in your examination. Okay, adequacy of rain gauge was also there. Then inconsistency, double mass curve thing was there. Okay, how to remove inconsistency, sir? You told us the technique, double mass curve. Okay, with the help of double mass curve, we can change the pattern of our data. And sir, adequacy of rain gauge, in which, sir, you told us about the optimum number of rain gauge formula. Okay, CV upon error whole square. I hope you remember that. Then after this, sir, we went on to discuss average depth of precipitation. Okay, presentation of data was there. Average depth of precipitation, sir. In average depth of precipitation, sir, you told us three formulas. The very first formula was arithmetic mean. Okay, the first formula was arithmetic mean. Second formula was Thiessen polygon. Okay, Thiessen polygon. Third formula was your isohydral method. Okay, isohydral method was the best method. So arithmetic mean was there, Thiessen polygon was there, isohydral was the best one. I hope you all remember all those formulas, three formulas. Then we went on to discuss DAD curve in the last class. Okay, let us see it. Let us see it. Wait a second. So what was DAD curve? DAD curve basically gives you areal distribution of. Wait a second. Yes, we have some slides here. Yes, so we discussed DAD curve. DAD curve, sir, represents areal distribution of a storm for a given duration. So, sir, you told me that whenever we have more area, then obviously the depth of rainfall stored will be less, but for a constant duration. And we have one more relation which you have to remember, that when duration is more, then depth of rainfall will be more. Okay, but for constant area. I hope you remember this. Sushil is saying daily I revise. Great. If you will do so, obviously you will become champion, Sushil. Okay, that is for sure. If you will do this, you will become champion in hydrology. No one can stop you from scoring maximum marks in examination. Okay, so at last also, in last class we also discussed about, wait a second, yes, in last class we discussed about frequency thing. Okay, I hope you remember what frequency was. See, any kind of rainfall event, any kind of flood event is basically uh, is having a particular frequency or probability. Okay, whose formula was 1 upon return period. I hope you understood the concept of return period. Okay, return period I have already explained to you beautifully in the last class. I hope you remember that. Then frequency of point rainfall thing was there. Okay, frequency of point rainfall thing was there, in which, sir, you told us about what is point rainfall, what is frequency, and sir, you told me that severe the event, or you can say higher is the magnitude of the event, be it rainfall or be it flood event, sir, the return period will be higher and its probability of occurrence will be lower, frequency will be less, and p plus q was equal to 1. Then this was the most important slide, sir. You told us that what is the probability of any rainfall event or flood event occurring r times in n successive years was given by ncr p power r q power n minus r. See, this was the most important formula. Many questions have been framed from here, so you remember this. And reliability and risk is very, very important. In reliability, sir, you told us that what is the probability that this flood will occur 0 times in n successive years. It will never occur. So probability was q power n. Remember this. And risk was 1 minus q power n. Risk is that this flood will occur or this rainfall event will occur at least once. Okay, so this was risk. I hope you understood in entire concept. You have also solved one question with the help of which you were able to understand it. Okay, so till here we have discussed fully. After this, I told you that if you want to find return period or probability for any kind of event, how you will do that. Okay, so the solution was, we have certain empirical methods, analytical methods, but empirical methods you are interested in. Sir, you told us about Weibull formula, California formula, Hazen formula. Sir, in Weibull formula, sir, you told us we have to obtain the annual time series for any kind of data. Okay, for any kind of record which you have, then we have to arrange it in descending order. We have to allot m values, we have to give the rank. Okay, then we have to use this formula, Weibull formula, California or Hazen, and simply find the probability or return period. Okay, and if that magnitude is not in that given table, then we have to interpolate or extrapolate, with the help of which we can easily find probability and return period. Okay, I told you I also solved one very small data question. Okay, see, such kind of small datas I should not have taken, but still for the sake of explanation I have. Okay, and for the sake of, you can say, cleanliness here, so that this thing doesn't become a mess here, so that's why I have taken a very small data. Okay, so you can see with the help of this small data I have arranged it in descending order, given ranks, wrote down the probabilities and return period. Say this formula is Weibull formula, and also try to interpolate. Okay, so I hope this thing was very, very clear to you. After this, now we are going to continue our lecture, and today we are going to discuss about intensity, duration, frequency curve. Okay, so this will be our today's goal. So I hope till here everything is very, very clear to you. Today we are going to discuss about intensity, duration, frequency curve. DAD curve is done. Today we are going to discuss about, wait a second, no, yes, today we are going to discuss about intensity, duration, frequency curve. Now what is intensity, duration, frequency curve? See this, you all know, in DAD curve we have three parameters: depth, area and duration. Yes or no? In DAD curve we have three parameters: depth, area and duration. Similarly, in IDF curve we again have three parameters: intensity, duration and frequency. Yes or no? Yes or no? IDF stands for intensity, D stands for duration, and F stands for frequency. Okay, sir, understood. Sir, how we will draw such curves? What is the significance of this curve? Okay, how they are related to each other? If duration is increasing, how intensity will change? If frequency is changing, then how intensity will change? So we have to understand the relationships. Okay, basically You need to understand, Sherman was one of the scientists, and according to him, intensity of rainfall was basically function of two things. Can you name those two things? See, you need to understand intensity of rainfall apart from these two parameters which I am going to tell you is also dependent on many other factors, but the two major dominant factors on which intensity of rainfall depends are, can you tell them in the comment box? Can you tell them? Try to answer it. Try to answer that intensity of rainfall is dependent on which factors. So according to Sherman, he studied huge amount of rainfall data, and after studying it, okay, he came up with certain empirical formula that I'm going to tell you. Yes, Sushil is saying duration. Okay, what else? See, duration and frequency both. Yes, Sushil is saying duration, return period. Perfect. Obviously, this is duration and this is return period. Frequency is none other than return period. You all know frequency is 1 by t. So obviously, yes, perfect. Perfect answer. This was the answer which I want to hear, obviously. So according to Sherman, listen very carefully. The equation which I am going to tell you has been asked in your engineering services prelims exam 2019. Okay, so this question was directly there. So according to Sherman, I is proportional to, or if I'm writing the empirical relationship between I, T and D, okay, it will be equal to I equals k t power x upon d plus a power n. Okay, so this is very important equation. Now let me explain this entire concept to you. Okay, how you have to understand this. Listen very carefully. So in this equation, you can see that intensity is related to return period and duration of rainfall. Okay, see all the remaining terms k, x, a and n, all these are constants and depends on region, what sort of catchment area is there. Okay, it is a all these are constant which depend on different factors. Okay, so we are not interested in that. Simply I will write here that this k thing, x, a and n all are constants. We are not interested in that. Okay, these are all constants. Okay, so k, x, a and n are constants. We are not interested in that. But sir, one thing which we can see here is that I is proportional to t and I is inversely related to d. Okay, this curve will be drawn between two parameters. Either it will be drawn between I and t, or either it will be drawn between I and d. Okay, so first we are going to understand the relationship between I and t. So can you predict what is the relationship? See, you need to understand, if we have higher intensity of rainfall, so that higher intensity of rainfall will occur in a longer period of time. Its return period, its recurrence interval will be more. Yes or no? This I have already told you. Yes or no? Tell me. If we have higher intensity of rainfall, so obviously its return period will be even more. Yes or no? Let us take an example. If we have 5 centimeter per hour rainfall, let us say its return period is 50 years. Such kind of event happens once in 50 years. But if we have 10 centimeter rainfall, 10 centimeter per hour rainfall, obviously its return period will be even higher. Yes or no? Since it is more, this event is of more magnitude, so obviously its return period will be even higher. Yes or no? Yes or no? So this we have already interpreted. So you need to understand that I is proportional to t. But sir, one thing is for sure, that whenever we are comparing, listen very carefully, whenever we are checking the relation between intensity and return period, okay, whenever we are checking relationship between intensity and return period, one thing which should be constant, is, can you tell me what has to be constant here? Sir, in both of these rainfall events, one thing which has to be constant is that the duration of rainfall. Yes or no? What has to be constant? Tell me, what has to be constant? Constant is duration. The third thing. Sir, you are studying relationship between intensity and frequency. You are studying relationship between intensity and frequency. See, this is none other than frequency. Okay, return period is 1 by f only. Okay, 1 by p. So this is the relationship between intensity and frequency only, and if this is the relationship between intensity and frequency, so obviously the third quantity will be constant. Okay. Similar to the case which we have discussed in DAD. In DAD, when we were discussing depth and area, then duration was constant. When we were discussing depth and duration, then area was constant. Similarly, here you need to understand duration of rainfall has to be constant. Let us say in the first case, rainfall has happened for 2 hours. Then in the second case also, if we are going to compare, rainfall has to be for 2 hours only. Yes or no? But if both of them are changing, sir, if both of them are changing, sir, then I will apply in this formula. Yes or no? But we are going to discuss them first. Firstly, we are going to study the uh, effect of frequency on intensity of rainfall. Then we are going to study the effect of duration on intensity of rainfall. So we are going to study them separately. First, we are going to study the effect of this on intensity, and secondly, we are going to study the effect of this on intensity. Okay. So we are going to discuss them separately. Okay. So first we are going to draw some graphs here. Okay. Wait a second. Yes. Now we are going to draw graphs. So tell me, if I am going to draw graph on, let us say on x-axis, we have, sir, we have return period. Okay. Try to tell me how this graph will be. Just try to answer where this graph will go. Okay. So this is x-axis. On x-axis, sir, I will plot return period. Okay. Right now, sir, we are interested in finding, the relationship between I and T. So let me draw it here. On the y-axis, we have I, obviously in centimeter or millimeter per hour, whatever may be the unit. And here on this axis, we have return period. Okay. T is what? T is return period. No problem, sir. So tell me how this graph will go. Will this increase or decrease? Can you tell me? Try to tell me how this graph will be. But sir, one thing is for sure, when we are trying to relate, whenever we are trying to relate I and T, sir, at that moment, sir, duration has to be constant. Yes or no? Sir, whenever we are trying to relate intensity and return period, then duration, the third thing, has to be constant. So I will write the relationship here. I will write the exact relationship here, that I is proportional to T. Yes or no? You can see here that I is proportional to T power X exactly, but let me write T here. Let us imagine that value of X is 1. But one thing is for sure, that for constant duration, yes or no, duration of rainfall is constant when we are comparing them. Okay. For constant duration. So now when you will draw such kind of graphs, you will see that these graphs will go up. Okay, like this. Let me draw first let me draw one graph. So I proportional T. So when this return period will increase, obviously let us take an example. If we have return period of 25 and if we have return period of 50, then at 25 years, obviously the intensity of rainfall which will happen will be less. But for 50 years, the intensity of rainfall will be more, because higher the magnitude of intensity of rainfall, higher will be its return period. Yes or no? This we have already discussed. But sir, one thing is for sure, that on this entire line, the duration of rainfall will be constant. Yes or no? Such as 8 hours, like this, 8 hours, 4 hours. Okay, like that. Let me write here. Let us assume that on this entire graph, when we are trying to relate I and T, the duration on this entire graph will be constant. Let us assume it to be 8 hours. Okay. Is this thing clear? High intensity, high return period. Perfect. But on this entire graph, duration of rainfall is constant, that is 8 hours. We have fixed it. Okay, that is for sure. Okay, let us draw one more here. Okay, it will be like this. It goes like this. So now you need to understand, this is for another constant duration. Here also I can see that I is proportional to T. Whenever your return period is increasing, I is also increasing. So this is the first graph which you have to remember. Now can you tell me within which two quantities we are going to interrelate? Can you tell me now which quantities we are going to relate? Can you tell me? Comment down below. So here we have linked I and T. Okay. Now in the next one we are going to link Tell me what quantities we are going to link here. Sir, I and T we have studied, but for constant duration. Now we are going to relate I and D. Perfect, Sushil. So can you tell me how will be the relationship between I and D? If duration of rainfall will increase, then what will be the impact on intensity of rainfall? Can you guess? Can you tell me physically what will be the significance of that? So let us assume here we have intensity, here we have intensity in mm per hour, and here we have duration now. Okay, perfect, Sushil, you are guessing it absolutely correct. We are more interested in duration now. Obviously D, let me write D here. Okay, now how this graph will go? Yes, these will be inversely related, absolutely correct, because you can see from here also Sherman equation. So I and D are inversely related to each other. Okay, I will be inversely related to D. But sir, how come? Sir, one thing which is crossing my mind is how come duration and intensity are inversely related to each other? I am unable to understand, sir. If duration of rainfall will increase, then intensity will go down. Is this the case? Yes, listen very carefully how this happens. Let me tell you. But yes, one thing is for sure that when we are considering I and D, then what thing will be constant? Can you tell me? What constant we have to make here? What thing will be constant here? Can you tell me? Kindly comment, everyone. Kindly comment, pay attention. Tell me what thing will be constant here. Perfect. T will be constant. Great. Tell me, will this graph go up or down? Yes, this is perfect. Let me write here. Here I will write that return period will be constant. Perfect. Perfect. Return period will be constant. But sir, I can see that when duration is increasing, intensity is going down, which means graph will be somewhat like this. Graph will be somewhat like this. Yes or no? Yes or no? Yes, it will be decreasing. Perfect. Yes, you are guessing it absolutely correct. But why? Have you understood the physical significance before it? Can you tell? Like here we can say that higher the intensity, higher will the return period, which means, sir, if we have a severe rainfall, obviously that severe rainfall does not happen every year or so. Obviously, severe the rainfall, it is likely to return more later. Okay, it will return, it will have a high return period. Yes or no? So this we have understood logically. Can you tell me this thing? So you need to understand here. You need to understand this. And one more thing which I have not written here, that on this entire graph, the return period will be constant. Let us say return period on this entire graph is constant. Let us say equal to 25 years, like that. Okay, on this entire graph, the return period will be constant. Okay, so I hope this thing is very, very clear to you. You are guessing it absolutely correct. Yes, now one more thing. Now I have to tell you the logic here. I have 3 more questions. Okay, 3 questions I have. These graphs will be like this. Now the very first thing which you have to understand is that why, sir, I and D are inversely related to each other. Listen very carefully. I will tell you the logic here. See, you must have observed that smaller intensity rainfall happens for long time. You must have witnessed this. Definitely you must have witnessed this, that smaller intensity rainfall, let us imagine small, very light rainfall is happening. That light rainfall can continue up to hours. Have you witnessed this? But if you will see, a very high intensity rainfall will last for a very less time. Okay, it will last, you can say it is short lived. Yes or no? Very high intensity rainfall is short lived, happens for moment, or you can say happens for 10 to 15 minutes, and then you will see it will stop. Have you witnessed this thing? Yes or no? Tell me if you have understood this concept. Okay, high intensity rainfall will occur for short duration of time, and you must have seen this. Definitely you must have observed it in your life once or twice, no matter how many times, but you must have witnessed this, that high intensity rainfall happens for a very short period of time, and very, very small little type of rainfall or light rainfall happens for long durations. You must have seen this. So this is the physical significance here. So sir, you are saying if we have high intensity rainfall that will last for a short time, okay, its duration will be very less, yes or no, and vice versa. Okay, so I hope this thing is very clear to you. Perfect, you are getting the concept correctly. You are absolutely correct here. If you want to understand, this is the perfect logic for both of them. Okay, so I hope it is very clear to you. So this thing is done. Now I have one more question. Tell me, let me see if you are able to understand this or not. Let us say we have a question in gate examination. Okay, let us say we have question here. It is written on this entire curve we have duration constant. Let us say duration is d1. On this entire I versus t graph we have constant duration of d1. Let us assume that. Okay, on this second graph let us say we have duration d2, constant duration d2, and on this third graph which is being plotted between I versus t, we have duration d3. Okay, I have assumed it to be 8, but let us say d1, d2, d3. So can you arrange them? Tell me which option will be correct here. D1, d2, d3. Both will, all the three will be equal. Or sir, d3 is greater than d2 is greater than d1. Or last option is we cannot establish relationship. Last option is none. So tell me which option will be correct here. Can you guess it? I am seeing your comments. Will you be able to guess it? See, the answer lies. Try to guess it. Answer is within this entire concept only. Okay, I have already made you understand the entire concept. Tell me what we'll get here. Sushil is saying A1 ABC. Tell me ABC, which will be correct answer. Try to tell me. You have to answer something. By your own logic. Okay, Sushil is saying A, Ajay is saying C option. Now let us check who is correct here. Listen very carefully here. See, you need to understand one thing. See, as you are moving upwards, intensity is increasing. Yes or no? Tell me. As you are going from here to here, as you are going from this graph to this graph, intensity is increasing. Yes or no? Intensity is increasing. Yes, sir. Now, if intensity is increasing, then duration will. If intensity is increasing, then duration will. Tell me. If intensity is increasing, then duration will. Tell me. If intensity is increasing, then duration will. Tell me. Will it increase or decrease? Sir, if intensity is decreasing, then duration will decrease. Perfect. Duration will decrease. Okay, so it means that d1 will be least. D1 will be least because when intensity increases, duration goes down. Yes or no? So if in examination they will give me some questions, so it means on going outwards we will have even lesser duration, because lesser duration rainfalls are generally of higher magnitude. That you have already told me, sir. Lesser duration rainfalls are generally of higher magnitude. Okay, so let us say, sir, that means which option is correct here? C option is correct here. Ajay is absolutely correct. D3 will be more, D2 will be less, and D1 will be even less. Perfect. Great answer. So I hope this entire concept is clear to you. Wait a second. Okay, so what I was, graphs are gone. No problem. We'll draw it again. So sir, you told us about three graphs. Three graphs over here. Okay, and if this is having constant duration of 8 hours, then this should have constant duration of 4 hours, and the last one should have even lesser duration. Okay, so when we are increasing outwards, sir, we can see one thing, that duration is decreasing. Okay, so we can see here, as we are moving outwards, duration decreases. Understood. Now one more question. Let us say if we have drawn the graph for intensity and duration, let us say for this first graph we have written period, constant written period of T1. For the second graph, we have constant written period of T2, and for the third graph, we have written period as T3. Okay, let us assume. Tell me which option will be correct here. Which one will be greater? Which relation is correct here? Let me see if you are able to understand this. Tell me, or C option. D is none. Tell me which option will be correct here. Tell me, tell me. Try to comment, everyone. Try to comment. T1, T2, T3, which will be more? Which will be more here? Perfect. See, just simple logic. If you will go outwards, intensity will increase. If you will go outwards, intensity will increase. And if intensity, yes, perfect. Intensity will increase. And if intensity will increase, sir, if intensity is increasing, it means we have more return period because I and T are proportional. Yes or no? Sir, I and T are proportional. It simply means that as we are moving outwards, we have more return period. Okay, which means first option will be correct. A option will be correct here. Okay, you all have guessed it correctly. Great. So I hope this concept is clear to you. So if this is of 25 years, so the second graph between I and D will be for, let us say, constant return period of 50 years, and the third graph for I and D will be, let us say, for constant return period of 100 years. Okay, like this. But yes, sir, this is for sure. As we are moving outwards, return period is increasing. Okay, so I hope this kind of graphs, whenever you will see, you will not get confused. So these are IDF curves, but how to draw it, sir? How to draw it, that I want to make you understand. Okay, see, listen very carefully. If you want to understand intensity, duration, frequency curve beautifully, I will explain it to you with the help of a beautiful example. Okay, so I hope this thing is very, very clear to you. Is there any confusion regarding this? You can ask, then I will give you an example with the help of which you will be able to understand. Okay, so now I'm going to make you solve this question. See, this question is very important. This question has been previously asked in GATE examination. Okay, so in GATE examination, this question has been asked. So let me check if you are able to solve, if you are able to find the maximum intensity of rainfall for 20-minute duration. Okay, so this question is important. So try to solve this question, then I will solve it and explain it to you, the beautiful concept of IDF curve here. So in this question, you can see we have the intensity of rainfall and time interval. For 0 to 10 minutes, we have 0.7 mm per minute intensity of rainfall. Okay, for next 10 minutes, we have given intensity is given to us. So for different durations, for 10 minutes, intensity of rainfall is given to us. But what this question is saying, find the maximum intensity of rainfall, for 20-minute duration. See, 10 minute is given to us in the question. For 10 minutes, we have 0.7. See, if they would have asked, find the maximum intensity of rainfall for 10-minute duration. So obviously for 10-minute duration, sir, I can see that 2.2 intensity is the highest. Yes or no? For 10-minute duration, the highest intensity is 2.2. I can simply see that. But they have asked for 20 minute. So can you guess it? See, listen very carefully here. Concept. Let me tell you the concept here. Sir, if we want to answer this question, see, how many questions can be framed here? Listen very carefully. How many questions can be framed here? Here we can have 8 type of questions. Why? Because the first question is, it can ask maximum intensity for 10 minute. It can ask maximum intensity for 20 minute, which they have asked in this question. They can ask, sir, maximum intensity for 30-minute duration. Sir, they can ask for 40-minute duration. At max, they can ask for 80-minute duration, because we cannot have rainfall more than 80 minutes, which our data is suggesting here. According to our data, we can see only 80 minutes we have. Okay, So maximum intensity which we can find, is for 80 minutes. Okay, duration, maximum duration is 80 minutes here. So maximum intensity for 10 minutes, maximum intensity for 20 minutes. So what we are doing here is we are changing the duration. Yes or no? And at max it can be 80 minutes. So tell me, will you be able to solve it or not? So I will solve for all of them. Okay, I will also find maximum intensity for 10-minute duration. I will also find maximum intensity for 20-minute duration, for 30-minute, for 40-minute, and so on and so forth. I will solve for each and every one. Sir, how? Now tell me, answer to this one. What is the maximum intensity when duration is 10 minutes? Tell me. This you have to tell. Can you see all these intensities are given to us in the question are for 10 minutes only. 10 minute, 10 minute, 10 minute. Simply see in this 10 minutes which is the highest intensity. Simply see which is the highest intensity, maximum intensity for 10 minutes. Can you tell me which is the highest one? Tell me. Everyone kindly comment. See, be participatory, otherwise you won't understand. This is a tough concept, okay? This has been asked in ESE mains examination. So yes, perfect. Great, Sushil, you are going good. Perfect. We have to form groups. Perfect. Yes, the answer is 2.2 mm per minute. That is for sure. Now for 20 minutes, what we have to do? For 20 minutes, we have to form groups of 20 minutes. See, the very first group will be from 0 to 20. The first 20-minute group will be from 0 to 20. Second group will be from 10 to 30. Third group will be 20 to 40, like this. Okay, like this we will form 20-minute duration. We will form 20-minute group duration. Okay, we will group 20 minutes and we will see where we are getting highest. So can you see here, sir, 20 minutes, this group, this group, this group, this group, first group, second group, third group, fourth group, fifth, sixth, seventh group. Tell me which one is the highest one. When you will sum them up, where you will get the highest sum. So this is the first group, second group, third group, fourth, fifth, sixth, seventh. So sir, according to me, third group 2.2 plus 1.5 will give me the highest value. Yes or no? Third group will give me the highest value. Perfect. Great, you have understood this. You have understood the concept here. So how I have to find the answer here? See, sir, you are saying when you will see for this 20 minute, in this 20 minutes, sir, you will see maximum rainfall is there. Okay, in this 20 minute maximum rainfall is there, you will say. So find, sir, how much see, this is 2.2 mm per minute. This is 2.2 mm per minute and total rainfall is for 10 minutes. So how much is the rainfall? Every minute 2.2 mm multiplied by 10, this is 22 mm. And in the next 10 minutes we have, in the next 10 minutes total rainfall is, sir, in the next 10 minutes we have total rainfall of 15 mm. Okay, sum it up. 37 mm. We have to find intensity. How intensity is found out? Simply, sir, depth divided by time. Rainfall depth divided by time. Yes or no? This is intensity. Yes or no? So depth is how much? Sir, depth is 37 mm. Highest depth is, maximum depth is 37 mm. Time is 20 minutes. Time is 20 minutes. Divide them. How much you are getting here? Kindly comment. 37 divided by 20. How much we are getting? Simply 1.85. Yes or no? Perfect. 1.85 we are getting here. So B option is the correct answer. Yes, B is the correct answer. It will be 1.85 mm per minute. Okay, 1.85 per minute. Perfect. So I hope gate question is very, very clear to you. Now let us say if they would have asked this question for, let us say, 30 minute. Can you tell me the answer yourself? I am not going to solve it. Just tell me if they would have asked. The answer to this one is 1.85 per minute. So you can see one thing, sir. What we can see, as duration is increasing, 10 to 20 minutes, as duration has increased, sir, intensity has decreased. From 10 to 20, duration has increased, but intensity has gone down. 2.2 to 1.85. Yes or no? Sir, duration has increased, but intensity has gone down. This is the exact relationship which we have already studied. This is the relation. Wait a second. This is the relationship which we have already studied. Yes or no? Sir, when duration will increase, 10 to 20, 20 to 30, sir, intensity will go down. Yes or no? So I hope this thing is very, very clear to you. Now tell me for the 30-minute. Tell me for 30-minute. Let me see if you are able to solve it or not. Try to solve maximum intensity for 30-minute. See, if you will group 30 minutes, how many groups you will have? So when you will group 30, okay, in 30 minutes, you will have these three, you will have these three, then you will have these three, then these three, then this one, and last this one. Okay, so these many 30 groups you will have, which will give you the highest sum. 2.2, 1.5, 1.2 will give you the highest sum. Yes or no? 2.2, 1.5, 1.2. These three will give you the highest sum. Yes or no? So 2.2 multiplied by 10 is 22. 1.5 multiplied by 10 is 15. 1.2 multiplied by 10 is 12. Sum it up. This is 9. This is 4. So 49 mm divided by 30. 49 divided by 30. Yes or no? 16.33. I hope you are able to understand. Why you are not telling the answer? See, all these questions are important for you. Try to solve. Okay, try to make groups, try to solve, give me the answer. Okay, is this thing tough? I have asked maximum intensity for 30-minute duration. You are not able to find it out. How come? Is this thing clear or not? Tell me. 30-minute duration thing is clear or not? I am unable to see your comments here. So 49 minute divided by 30 mm is what? It is 1.63333 like this. I think this is the correct answer. Yes or no? Yes or no? Tell me. Similarly, you can find for 40-minute also. Yes, we will. Perfect. So this is clear. Now you can see one thing. Patterns you have noted. Now we have many patterns here. Okay. Sir, according to the pattern, we can see that as duration is increasing, intensity is going down. And if you will find maximum intensity for 40 minutes, okay, this now we can easily find. If you want to have a group of 4, which four will be the highest? These 4. No, sir. 1.3 we have to add. These 4 will be the highest. Yes or no? So if we want to add these 4, so 22, 1.5 15, 12 and 13. When you will sum it up, you will get it as 62 minutes. Yes or no? 527, 7512, 1 carry. So 62 mm divided by 40 minute. Yes or no? 1.5, 1.55. 1.55 will be the answer, I guess. Yes or no? So 1.55 will be the answer. So now you can see that intensity is going down. Similarly, you can find for any kind of duration. Yes, 1.55 is the perfect answer here. So I hope this thing is clear to you. So if in examination they are saying to draw maximum intensity and duration graph, will you be able to draw such a kind of graph when such data will be given to you? Now listen very carefully. If we want to draw the graph here, between intensity and duration, you can draw it. See, for 10-minute duration, the maximum intensity is, sir, for 10-minute duration, listen very carefully how to draw graphs. Okay, from this question only, this question has been asked in GATE examination. They have only asked for 20-minute duration. I am telling it for all the durations and how to draw graph from such data. So for 10 minutes, sir, I will write 2.2 here. Yes or no? For 20-minute intensity is, for 20 minutes our intensity is 1.85. Yes or no? Sir, for 30-minute intensity is 1.633. Now the gap is reducing. Then for 40-minute the value is 1.55. Similarly for 50 minutes, 60 minutes, 70 minutes, and at max for 80 minutes. At max for 80 minutes. For 80 minutes, sir, we have to total sum of the entire depth of rainfall divided by 80 minutes. That will be the answer. Yes or no? So these points we have obtained. These points 2.2, 1.85, 1.633, 1.55, and then we have to join them. Yes or no? So this is I versus D. And you can see as duration is increasing, intensity is going down. As duration is increasing, intensity is going down. This you have already discussed. Yes or no? As duration is increasing, intensity goes down. Yes or no? Tell me. I hope this question has made the entire concept clear here. Yes or no? So I hope this is clear. Perfect. So now shall I give any kind of question? Will you be able to solve or not? If I ask you to draw intensity, duration, frequency curve, so will you be able to draw it or not? Tell me. Let me give you one question. Let me check if you are able to do it or not. Kindly comment yes or no. Then I will give you one question here. Okay. Everyone kindly comment. Will you be able to draw such kind of intensity, duration graphs? So here comes the question. Okay. I will give you 2 or 3 minutes and expect from you that you will be able to solve such kind of question. Yes, perfect. So you are saying, Sushil and Yugal, all of you are saying yes. So let me see if you are able to solve this kind of question. See, in this question, let us read out the question. What they are saying, compute and draw storm hydrograph, okay, maximum intensity duration curve and maximum depth duration curve. 3 things they have asked, okay. They are asking 3 things from us. In this question, they are saying to draw three things, okay. See, this question you have to solve yourself. I will only help, and after 2 or 3 minutes when you will solve it, I will help. Okay, I will see that if you have done it correctly. So first thing is storm hydrograph. Storm hydrograph is nothing, simply intensity versus time for different durations you have to do. Then maximum intensity duration curve, just now I have also told you how to draw it. Okay, I have also solved one example also, maximum intensity duration curve. And lastly, they are asking you to solve or draw maximum depth duration curve. Okay, maximum depth is nothing. See, depth is nothing. Maximum depth, let us have a quick recap here. See, intensity is 1.85 mm, but depth is how much? Depth is 37 mm. This is depth. Maximum depth in 20 minutes is how much? 37. Maximum depth in 30 minutes was how much? It was, I guess, 49 mm. Maximum depth in 40 minutes, how much it was? I think in 40 minutes it was 62 mm. Yes or no? Sir, for 10 minutes the maximum depth is 22. For 20 minutes the maximum depth is 37 mm. For 30 minutes the maximum depth was 49 mm. For 40 minutes the maximum depth was 62 mm. Only depth. When you will divide depth by duration, then intensity you will find. Then you will get the intensity. But if they are only asking about the maximum depth, then you will draw maximum depth versus duration. Is there any issue? You can simply write these values and draw them. Yes or no? You can simply write these values and draw them. Okay. So Sushil, I hope you have understood about maximum depth duration curve. When you are plotting depth only without dividing it by time, that is depth. Yes or no? Arey, this is maximum depth, nothing else. This is maximum depth, nothing else. This is maximum depth. Simply for 10 minutes, what is the maximum depth? For 20 minutes, what is the maximum depth? For 30 minutes, what is the maximum depth? Okay. So I hope this thing is clear to you. Maximum depth you have to plot. Versus duration. So I will draw it, don't worry. First, try to solve it yourself. See, if we are, see in this question, one thing is there, they have given you cumulative precipitation. They have given you accumulated precipitation, accumulated rainfall they have given you. So what I will do to get the rainfall in the first 30 minutes. See, in the first 30 minutes, sir, I can see the rainfall is 5 centimeter only. If I want to write incremental precipitation here, listen very carefully. If I want to write incremental precipitation in centimeter here, how I will write? See, cumulative means 7.5 centimeter rainfall has happened from starting 0 to 60 minutes. Okay. From 0 to 67.5 rainfall is there. So how much rainfall will be there when you are asking here for 30 to 60 minutes? Can you tell me what we have to do? we have to subtract. So from starting to 67.5, from starting to 30 is 5. From starting to 67.5, from starting to 30 is 5. So what will be the incremental rainfall in 30 to 60? So we have to subtract 5 from 7.5. It will be 2.5 centimeter. Yes or no? Yes or no? Tell me, is this in clear? How we are finding incremental depths? Now, for similarly, from 60 to 90, see, from 0 to 90, 8.5 centimeter. From 0 to 60, 7.5 centimeter. So from 60 to 90, how much incremental depth of reduction we have? 8.5 minus 7.5. That is 1. Yes or no? Is this thing clear? Simple. Lastly, we have from 0 to 120, we have 9. From 0 to 90, we have 8.5. So obviously in the last 30 minutes, the rainfall which we have here is simply subtract 8.5 from 9, we have 0.5 centimeter. Okay. So this is the incremental precipitation. Simple. It's very simple. Now you carry on with this question. I am giving you 2 minutes time. Draw the storm hydrograph. Okay. Draw maximum intensity duration curve and also draw maximum depth duration curve. Then I will check your question answer in 2 minutes. Okay. Hydrograph is nothing. Intensity versus time. See, what is the intensity in the first 30 minutes? In the first 30 minutes, intensity is 5 upon 30 minute. Okay. In R, if we talk it in R, so obviously 5 upon 30 minutes, you need to convert 30 minutes into R. Okay, that you can do. Plot. See, you have 4 durations, 0 to 30, 30 to 60, 60 to 90. Like this, you can draw the graph for intensity versus time. Okay, just try to solve it. Let me see what sort of hydrograph, what sort of intensity distribution curve you are drawing. I'm giving you 2 minutes time. Solve, everyone. Yes, perfect, Sushil. So first we have to draw the hydrograph. Okay. So first we are going to draw the hydrograph here. See, hydrograph, let me draw here only. In the next slide, I will draw. Let me check if we have slides. We have it. Okay, if you will draw the hydrograph here, okay, so for the first 30 minutes, obviously in hydrographs, the duration will be 0 to 30, 30 to 60, 60 to 90, and from 90 to 120. Okay, if we talk of intensities, so you can see intensity in the first 30 minutes. Let me write here for first 30 minutes. For first 30 minutes, the intensity will be how much? 5 centimeter divided by 30 centimeter. 30 centimeter means half hour. Okay. So this will be equal to 10 centimeter per hour. Yes or no? Then for second 30 minutes, intensity will be, for second 30 minutes, intensity will be 2.5 upon 30. 2.5 upon 30. 2.5 centimeter upon 30 minutes. 30 minutes mean half hour. Okay. 30 minutes means half hour. So this will be 5 centimeter per hour. Just double of it. 5. Okay. So I hope intensity part is very, very clear to you. Similarly, for third 30 minute, intensity will be 1 divided by 0.5. Intensity will be 1 divided by 0.5 hour. 30 minutes means half hour. You all know this. And similarly for last 30 minute, we have 4 30-minute durations here. Intensity is 0.5 centimeter divided by 0.5 hour. It is 1 centimeter per hour. So when I will draw it, it will be like this: 10, 5 to 1. So this is, let us say this is 10. Okay, this is 10. We will write 10 centimeter per hour here. Then we have 5, just half of it. This is 5. Okay, half of 10 is 5. Then 2 is from 60 to 90 we have 2 centimeter per hour. From 60 to 90 we have 2 centimeter per hour. So this is 2 centimeter per hour, and at last we have 1 centimeter per hour. So this will be I versus T graph. This is 1 centimeter per hour. Let us take this as 1 centimeter per hour. So here we have intensities, that too in centimeter per hour, and here we have time duration, and that too in minutes. Okay, we have written in minutes here, so no problem. So this is 10, this is 5 centimeter per hour, this is 2 centimeter per hour, this is 1 centimeter. So this is your hydrograph. Okay, sir, this is my hydrograph. This is my hydrograph. Sir, this thing is clear to me. First part is done. Okay, first part is done. Sir, hydrograph is done. Now second part. Perfect. Okay, now we are going to discuss about, I hope this hydrograph thing, if you have drawn it correctly. I'm just assuming it that you have drawn it correctly. Now we will move on to the second part, which is maximum intensity duration curve. So for maximum intensity duration, sir, you have told me, let me write here. We don't have a space on this page, so we'll take another page here. Yes, listen very carefully. See, in IDF curve, one thing which you have to understand, for IDF curve, every time I will consider maximum intensity only. Sir, we have grouped 10 minute and we have checked where we are getting the highest. Sir, we have grouped 20 minute duration and we have checked where we are getting the highest. Sir, we have grouped 30 minute duration and we have checked where we are getting the highest. So for intensity duration curve, every time, sir, I will consider maximum intensity in any kind of duration. In 10 minutes, sir, what is the maximum intensity? Sir, when rainfall is of 20 minutes, sir, what is the maximum intensity? Like this. Okay, if rainfall is for 30 minute duration, sir, what is the maximum intensity? We are interested in maximum intensity. Why? Because obviously whenever you have to design any kind of hydraulic structure, in that case you are interested in maximum intensity only. Yes or no? So one thing, let me write here. one thing let me write here first. Okay, let me write one point here, very important point, that whenever we are going to draw IDF curve, let me write here, IDF curve is plotted for maximum rainfall intensity, is plotted for maximum rainfall intensity. This is important. Okay, so here we are also interested in maximum intensity, maximum rainfall intensity, and duration. But one thing is sure, for constant return period, intensity and duration will draw, but for constant return period. But sir, how we'll do that? How we'll do that here? Tell me. So let us take some graphs here. Sir, you have told me, let me say we have duration here. Here we have rainfall. Okay, now we'll take maximum duration for 30 minutes, then for 60 minutes. See, when we'll group, sir, total, let me check here, we have total 120 minutes. So how many groups we can form? We can have 30 minute group. Sir, we can have 60 minute group. Sir, we can have 90 minute group. We can have at most a group of 120 minute. Okay, so how many groups we can have? 30 minute, 60 minute, 90 minute and 120 minutes. So total, in total, sir, how many durations we can have? 30, 60, 90 and 120. 30 minutes, wait a second, 60 minutes, 90 minutes and 120 minutes. So this is these are all the durations for which we can draw. Okay, so sir, kindly draw here. Now for 4 durations we will draw 0 to 30 like this. Now I will write the values with the green ink. So for duration 0 to 30 minute, duration is in minutes only, obviously. 0 to 30 minutes, 30 to 60, 60 to 90 and 90 to 120. Okay, so total 4 30-minute durations we have. Perfect. I will come to this. Okay, we'll see if your answer is correct or not, Sushil. So let me write the rainfall. See, so for the first 30 minutes, sir, we have 5 centimeter rainfall. Here we have, let me check here. Here we have 5, 2.5, 1 and 0.5. 5, 2.5, 2.5, 1 and 0.5. Okay, so for 30 minute duration, if I'm talking of only 30 minute duration, so let me write 30 minute duration here. So for the first 30 minute we have 5, for the next 30 minute we have 2.5, for the next 30 minute we have 1, and for the next 30 minute we have 0.5. Simple. Now combine 60 minute. Tell me for the first 60 minute how much rainfall we have. Tell me for the first 60 minute how much rainfall we have. Sir, for first 60 minute we have 7.5 centimeter rainfall. Sir, for the next 60 minutes, sir, we have 3.5. For the next 60 minutes, sir, we have 3.5. Group 60 minutes. Group 30 minutes and make it, combine it to form 60 minute duration. Yes or no? Yes or no? And similarly, for last 60 minute, we have 360 minutes here. This is the first 60 minute. This is the next 60 minute. This is the third 60 minute. So for the third 60 minute, we have 1.5. Now, form groups of 90 minute. So for the first 90 minute, how much rainfall we have? 5 plus 2.5 plus 1. It will be equal to 8.5. Yes or no? 8.5 centimeter. And for the second 90 minute duration, we have 2.51, 3.5, 3.5 is 4. 4 centimeter. Yes or no? So when we have combined 30 minute durations to form group of 90 minutes, we have 8.5 and 4. And if we will combine all of them to form a group of 120 minutes, the total rainfall which we will have is 5, 2.5, 1 and 0.5 is none other than 7.5, 8.9. Okay. It will be 9 centimeter. Now, sir, if we will check, the highest values in all of them. Sir, if we are interested in finding the highest values, then sir, it is for sure that in 30 minutes, 5 centimeter is the highest. In 60 minutes, 7.5 centimeter is the highest. Yes or no? Yes or no? We are interested in maximum depth. Sir, the question itself is saying, draw maximum intensity, draw maximum depth. That's why, sir, we are interested in maximum depth. Which depth is maximum in 30-minute duration? Sir, obviously 5 centimeter. Which depth is maximum in 60 minutes? Obviously 7.5 centimeter. Which depth is maximum in 90-minute duration rainfall? Sir, obviously 8.5 centimeter. And sir, which depth is maximum when we are talking of 120 centimeter? Only one is there, and that will be the maximum one. That is 9. Yes or no? Yes or no, Sushil? And Yugal, I hope it is clear to you. Okay, perfect. Now, if we want to draw the curve, you are saying what is maximum depth duration curve, I will draw here. Okay, what is maximum depth duration curve? It is very simple. See, wait a second. See, this is maximum depth duration curve here. On this y-axis, I will plot maximum depth, and on the x-axis, I will draw the duration. Okay, so let me write the maximum depth here. Okay, I hope this graph is visible to you. And on the x-axis, we have duration. So, sir, obviously we have 4 durations here. The first is 30 minute, the first is 30, then 60, then 90, and then 120. Okay, obviously we have put duration here in minutes. So for 30 minutes, what value we have? Sir, for 30 minutes, the value which we have here is 5 centimeter. Okay, let us say this is 5. Let us say this value is 5 centimeter. Then for 60 minutes, we have 7.5. Wait a second. Let me start this graph from here. So 5 is the value. First value is 5. First value is 5. For 60 minutes, we have 7.5. So 7.5 will be here. Then for 90, we have 8.5. Then for 120, we have 9. Okay, this is 5, this is 7.5, this is 8.5, and this is 9. So this is the maximum depth versus duration curve. This is the maximum depth versus duration curve. It is like this. It will increase. Yes or no? It will be like this. Okay, so I hope all these points are very, very clear to you. So this is your maximum depth duration curve, which has been asked in a question. I hope this maximum depth duration curve is clear to you. Clear? Now at last we have to draw maximum intensity curve. No problem, Sushil. But since you have tried it, since you have tried that question, it will be in your focus for the next time. Okay. So just I want you all should try. What I want that you should try at least. Okay. So no problem. No matter question has become wrong, but still you have tried. That is more important. Okay. Okay. So now we have to find maximum intensities. So let me write here. Yes, so let me write here maximum intensity. Now if we are interested, I hope this color is visible to you. Is this color fully visible to you? Yes, maximum. So this is maximum intensity for 30-minute duration. Okay, maximum intensity for 30-minute duration. Can you tell me? So obviously, sir, for 30-minute duration, the depth is 5 centimeter. Okay, for 30-minute duration, what maximum intensity we have? We have it as 5 centimeter divided by 30 minute. Okay, 30 minute is 0.5 hour, you all know. So it will be 10 centimeter per hour. Okay, 10 centimeter per hour. This is the intensity for 30 minute, maximum intensity basically. Now, maximum intensity. Tell me what will the maximum intensity for 60-minute duration? Tell me what will the maximum intensity for 60-minute duration. Can tell me the answer? Find it. Tell me the intensity for 60-minute duration. Yes. Point 0.16. No, dear. Listen very carefully here. See, 5 upon 30 you will not do. You will find intensity in centimeter per hour. Okay, 5 upon 30 is not the answer. Yugal. Okay, convert that minute thing into hour. Okay, so maximum intensity for 6-minute duration will be, similarly we have to find maximum intensity for 90-minute duration. At last we have to find maximum intensity for, see, intensities are written on the, in this bracket we have the intensities, yes or no? So maximum intensity for 60-minute duration is 7.5 centimeter divided by 60 minute, and 60 minute is 1 hour. 60 minute is 1 hour, so answer is 7.5 centimeter per hour. Then for 90-minute duration, maximum intensity is 8.5 centimeter. This is the maximum depth divided by time. See, 90 minute is 1.5 hour. You all know this. 90 minutes simply means 1.5 hour. Okay, perfect. Perfect. It is 1.5 hours. So divided, how much you are getting here? This will be 5.67. Okay, yes. This will be 5.67 centimeter per hour. And at last, we have 9 centimeters divided by 2 hour. Divided by 2 hours. Okay, so it is 4.5 centimeter per hour. Okay, so all these are your maximum intensities. So I hope this is very, very clear to you. So 10, 7.5, 5.67 and 4.5. Now we'll simply plot them and get our maximum intensity duration graph. Okay, let me see if page is left here. If not, we will carry one of them. So now we will 10, 7.5, 5.67 and 4.5. Let me draw here. This will be our maximum intensity duration graph. Okay, here on the x-axis, y-axis we have maximum intensity. On the x-axis we have time duration, and that too in minutes. Okay, so obviously we will write the duration here: 30, 60, 90, 120. Duration will be in minutes. Here I will write maximum intensity. Okay, this is your maximum intensity, and that too in centimeter per hour. It will not be in centimeter per minute. Basically, you can write it, but yes, it will be better if you write your maximum intensity in centimeter per hour. Okay, so the first value is 10. The first value is 10. Let me write 10 here. Then we have 7.5. Then we have 5.67, and at last we have 4.5. 10. Then what value? 7.5, 5.67. At last we have 4.5. So these are all the values. Let me join it with the help of a straight line. Yes, a smooth curve we have made here. Okay, so this is 10, 7.5, 5.67, 4.5. So this is your maximum intensity duration curve. See, all the things which have been asked in question we have drawn. Okay, I hope these points are very, very clear to you. Now at last we have also drawn the maximum intensity duration curve. Is this clear? Basically I want to show you that maximum intensity comes from maximum depth. First you have to group them and find the maximum depth. Yes or no? First you have to find, by groupism method you have to make highest group. You have to make group of maximum depth. Then you will find maximum intensity by dividing the maximum depth by time. So one thing which we have understood here very clearly, sir, that for I've written here that for IDF curve we are interested in maximum rainfall intensity, and in maximum rainfall intensity, sir, you have told me that whenever we are going to find maximum rainfall intensity, whenever, sir, we are going to find maximum rainfall intensity, I will only use maximum depth. Okay, we are only interested in maximum depth. So we can draw maximum depth duration graph, and we can also draw maximum rainfall intensity graph. It's up to you. Is this thing clear to you? Tell me. If this concept is clear to you, then we'll move on to the next one. So intensity, duration, frequency curve is fully clear to us. I have given you the entire concept here. Now we'll move on to the next thing, which is world's greatest rainfall. So this question is also clear to you. This question is fully clear to you. Now I hope why 10 minute, 20 minute, and 30 minute groups we are making. Okay, so here if you would have drawn intensity duration curve, you would have got 8 points: 10, 20, 30, 40, 50, 60, 70, 80. This question. Okay, and maximum depth graph would have gone upwards, but maximum intensity graph goes downwards. Okay, so I hope this thing is clear to you. So till here, I hope entire concept is clear to you. So you can see depth graph going upwards and intensity graph going downwards. Now tell me the answer to this one, then we will read out the last topic. Tell the answer to this one. This question has also been asked in GATE examination. Very simple one. What is an ISO height? What is an ISO height? Can you tell me? So an ISO height is a line joining point of. It's very simple. ISO means same. Height means rainfall. See, ISO therm means equal temperature. Okay. Equal temperature means isotherm. On this line, if we have temperature on all the points, see all the points joining this, all the points which are joining to form this line have same temperature, then I will call this line as isotherm. But if this line has same rainfall, then I will call it as isoheital line. See, this line was also drawn in your isoheital method. Okay, yes or no? Tell me. This was also drawn in isoheital method. Yes or no? I am able to see your comments. Great. Perfect. Now we'll move on to the next topic, which is none other than world's greatest observed rainfall. See, what is the meaning of world's greatest observed rainfall? See, many scientists have studied different parts of world. Okay, and in different parts of world, they have came up to the conclusion that, see, you all know that whenever we'll study data, okay, let us see, let us try to understand that we have certain areas, and in that areas maximum rainfall has happened. And when those scientists have studied this maximum rainfall data and they have observed it, from that data they have derived one empirical equation. See, whenever a scientist has to come up with empirical equation, first he has to do many observations. First he has to take too many observations, he has to collect too many data, and from that data he can do the line of best fit and he can get the graph, or you can say he can get the equation from here. Okay, so many scientists across the world have come up to the common equation. Okay, and that equation is given by, let me tell you what that equation is. But basically, world's greatest observed rainfall simply means that by looking at that equation you can simply find the world's greatest rainfall that can be observed in that part of the area. Okay, simply by putting the duration. So let me write one point here with the help of which you will be able to understand. Let me write one point here. So maximum rainfall, okay, world's greatest observed rainfall is none other than maximum rainfall that is observed, So scientists have studied too many data, collected too many data, and from that data they have given an equation. So that equation I am going to write here: maximum rainfall that is observed in any part of the world, that is observed in any part of the world, be it any part, is given by which equations are PM equals 42.16 42.16 d power 0.475, d power 0.475. So this is your equation, and this d is duration, this d is duration, and that too in hours. See, this is an empirical equation. So in empirical equation, it is mandatory to follow the units which the scientists are telling you. So simply you have to put duration here in hours. Okay. And this is your maximum depth. This is the extreme rainfall depth. This is the extreme rainfall depth in which we are interested. And this will be in centimeter. Okay. This will be in centimeter. So I hope this thing is clear to you. So it is the extreme rainfall depth. Okay. This is the extreme rainfall depth. I hope this thing is very, very clear to you. So simply by putting the duration of rainfall, okay, simply by putting the duration of rainfall, you will be able to find extreme rainfall depth in any part of the world. You can apply this equation in any part of the world. Okay, let us say you are in Brazil, let us say you are in India, let us say you are in Kerala, or be it any part of the state, country, be it anywhere, be it any part of the world. Simply put the duration in 1 hour. If you will put 1 hour, you will get extreme rainfall depth in centimeters. Okay, so remember this general kind of equation. Obviously it will not be true for every place, but yes, it is more or less correct because scientists have studied too much of data. Okay, so I hope this thing is very, very clear to you. Is this thing clear? Tell me, is this thing fully clear to you that what is maximum world's greatest observed rainfall? This equation is important because it has been asked once. Okay, clear. Now we'll study the last topic, which is probable maximum precipitation. Is this thing clear? Kindly comment yes. Perfect. Perfect. So this is clear. Now we'll move on to the last topic, which is probable maximum precipitation. So probable maximum precipitation is PMP. Okay. PMP. Probable maximum precipitation is PMP. So what is the meaning of PMP? See, PMP means, you all know that precipitation is probable in nature. Okay. Sometimes you will have more precipitation, sometimes you will have less precipitation. Okay. So PMP means maximum precipitation. No matter what happens, precipitation cannot be greater than this value. Precipitation cannot be greater than this value. This is probable maximum precipitation. Like, tell me, how much is the what is the best rank that you can secure in GATE examination? Tell me, what is the best rank which you can secure in your GATE examination? Tell me the best rank which you can get here. Kindly comment everyone. Tell me the best rank which you can obtain in GATE examination. Can you tell the rank? The best rank. See, the best rank which you can get in GATE examination is All India rank 1. Yes or no? So that is the best part, or this is the best efforts, or you can say the best result which you can get by applying your best efforts. So similarly, in a catchment area, at a certain rain gauge, at a certain station, the maximum precipitation which can happen physiologically, meteorologically, okay, practically possible, that is your, yes, that is your probable maximum precipitation. No precipitation can be greater than this value at that rain gauge. Okay, so let me write here. Let me write here one point. Let me write one point here. So what is probable maximum precipitation? See, it is known as PMP. It is abbreviated as PMP. So probable maximum precipitation is defined as the greatest or extreme rainfall is defined as the greatest or extreme rainfall. Let me write PMP here. Greatest or extreme rainfall of a given duration that is practically possible, of a given duration that is physically or practically possible over a basin or a station. Practically possible over a station or basin. Yes or no? So this is practically highest value of rainfall that can happen in a basin at a particular rain gauge. Okay. So the formula to this is PMP is equal to, see, obviously this value will be more than average value. Okay, obviously this value will be more than average value. See, you should understand one thing. Let us say in a class of 50 students, okay, in a class of 50 students, all have got some marks. Okay, there was a test and 50 students have attempted that test, and in that test all have got some marks. So obviously the mean marks, let us say the mean marks of class was 65 marks. Okay, now obviously the topper of this class will be very ahead of mean. Okay, he will be somewhere around 90 or 95 like that. Okay, out of 100 obviously. And the guy or the student who has scored the least marks will be lower than the mean. Yes or no? Lowest marks or the last one, let us say he has secured only 5 marks. Okay, so the lowest one will be very less from mean, and the highest one will be very higher, you can say on the higher side of mean. So PMP is simply average precipitation. PMP is simply average precipitation, or simply mean annual rainfall, plus K times sigma. You have to go ahead. You have to go ahead from mean in order to get the highest value. You have to go ahead of mean in order to get the highest value. Yes or no? I hope you are able to understand this. So let me write the meaning of P bar here. P bar is what? P bar is mean annual rainfall. Okay, let us say you have a data of 50 years in a certain catchment area at a particular rain gauge. You have data for 50 years, last 50 years. In 2022 this much of rainfall is there, in 2021 this much of rainfall is there. Simply take average. Simply take average of that series. So mean annual rainfall of a given series. Okay, so P bar is mean annual rainfall of that series. K is what? K is frequency factor. K is frequency factor. This you will understand in probability distribution. Sigma is what? Sigma is standard deviation. Okay, sigma is standard deviation. Sigma is standard deviation of this series. Okay, sigma is standard deviation of this series. So I hope you have, if you have a data of 50, if you have a data of 50, you can simply find mean and standard deviation. Okay, this we have already done in the optimum number of rain gauge thing. Okay, so simply put mean and standard deviation, put frequency factor. See, if this frequency factor is to be very high, if you want to go to the topmost side, then obviously this K value should be very high. Okay, somewhere around 14 to 15. So this is your probable maximum precipitation. I hope this thing is very clear to you. So basically PMP is used for design of large hydraulic structures. Okay, so PMP is used for design of large hydraulic structures, because if those large hydraulic structures will fail, it will cause huge problem. That's why we have to be very sure. We have to prepare. See, if you want to secure all India rank 1 in gate, obviously you will put your best efforts, give your best efforts. It will cost you more, it will require more efforts, more time you have to give. Obviously you have to give best efforts. Similarly, when we are designing a very large hydraulic structure such as a very huge dam, let us say TAYARI dam or Bhakra Nangal dam, such kind of dams are basically designed for PMP, so that no matter what, they are able to resist the highest rainfall. No matter what happens, they are able to resist the highest rainfall. If this rainfall also happens, basically the probability of occurrence of such events are very less. Okay, such kind of events basically will not happen, but still my structure is ready for it. Still my large hydraulic structure is ready for it. Okay, so that probability of failure decreases. Yes or no? So that probability of failure decreases, so that it has so that it has less probability of failure. Okay, so I hope this thing is very clear to you, PMP thing. With this, everything is done. Everything is done. I hope it is clear to you. Perfect. Tell me if you have understood the entire concept here. So should we take some questions or end our class? Tell me. Should we solve some questions or end it? Tell me, what do you want? Should we solve some questions or end our class? Tell me, everyone. Okay, question. Thank you, dear. Thank you. Question. Okay, so we'll solve some 2 or 3 questions, then we'll end our class. So tell the answer to this one. Depth, area, duration curves of precipitation at a station would normally be like. Tell me, how would they be? So depth, area, duration curve. So depth, area, duration curve. Are they concave upwards, convex? Tell me the answer to this one. You have to tell me. Wait, one problem is there. See, here you have to make decreasing. Otherwise, B and D option will be same. Now tell the answer to this one. Let me see if you are able to understand it. Thank you, dear. Tell me the answer to this one. Tell me the answer to this one. From upward side, if you will see, they are convex, or from upwards they are convex and from downwards they are concave. Yes or no? Sushil is saying C answer. Let me see if you are correct or not. I have told you about DAD curve. Okay, sorry. We have deleted that slide, but no issues. See, DAD curves are like this. Okay, DAD curves are like this. So they are upward from upwards they are convex and from downward they are concave. And one more thing, when we are increasing, when we are going outwards, duration increases. Here we have 6 hour, here we have 12 hour, here we have 1 day, like this. This I have already told you in class when you have discussed DAD curve. So for this, duration is least. When we are going outwards, duration increases. So curve is concave downwards. Curve is concave downwards with duration increasing outwards. With the duration increasing outwards, because this graph is 6 hour, this is 12 hour, this is 1 day. Okay. So curve is concave downwards. From downward side it is concave, and with duration is increasing outwards. Okay, so B option is correct here, not C option. So concave downwards, duration increasing outwards. Is this in clear, Sushil? Tell me, I hope you remember this. I hope you remember this DAD curve. Just see the DAD curve which I have drawn in the class itself. Okay, see the DAD curve which I have shown you. Now we'll move on to the next question. So I hope this question is very, very clear to you. Wait a second. Now we have one more question, this one. So tell the answer to this one. By DAD analysis, the maximum average depth over an area of 104 km square due to 1 day storm is this much. Area is 104 km square. 1 day is the duration, and the depth which we have received is 47 centimeter. For the same area, the maximum average depth for 3 day. For the same area, the maximum average depth for 3 day. Now they have increased the duration from 1 day to 3 days. Storm is for 3 days. So what will be the depth here? What depth you will expect here? ABC. Tell me what depth you will expect here. Tell me what answer we'll get here. What depth we are expecting here? Tell me. Perfect. B option, because since depth and duration are proportional to each other, we have already discussed, if duration will increase, depth will increase. Okay. So B option is correct here. Perfect. Perfect. Great. Now we have one more question here. Tell the answer to this one. If the maximum depth of a 50 or 15-hour rainfall at Bhubaneswar is 260, return period is 50 years. Okay. Return period is 50 years. Rainfall duration is 15 hour. Depth is 260 mm. Return period is again 50 year. Okay, return period is again 50 year. Duration of rainfall is 3 hour. Tell me what depth you will expect. Tell me what depth you will expect here. Tell me answer to this one. No, Sushil. Exactly not will not multiply 47 by 3. No. Wrong. Because you need to understand depth and area have certain depth and duration have certain relationship. Not exactly proportional. Okay. Obviously it will increase, but not exactly 3 times, because we have certain relation here. Depth power duration power x, like this thing. Okay, some exponent will be there, so that's why not exactly 3 times, but yes, it will increase. Now tell the answer to this one. Yes, so the answer will be, now you can see duration has decreased, so obviously depth will also decrease. A option is correct. You are getting it absolutely correct. Perfect. So this is it. We will end our class today and we will catch up in the next class. Wait a second. Too many slides are there. So I hope you have enjoyed all the lectures and understood all the concepts of precipitation chapter. See, precipitation chapter is very, very important. So I hope you have liked it and understood all the topics. Okay. Perfect. So we will catch up in the next session. So thank you everyone. Stay blessed. Take care. We'll catch up in the next session tomorrow, from where we'll start our abstraction from the next chapter. Okay. Third chapter will start. Okay. You are a little confused. A little roadmap of gate 24 working. See, first try to cover syllabus quickly. Okay, if you have not covered it, then focus on all the things. See, first 3 things are there basically. First, you have to cover all the syllabus. Secondly, you have to revise it. Thirdly, you have to give test series. Okay, so if you are a working student, take out time for yourself. Let us say 5 to 6 hours daily. Okay, 5 to 6 hours daily you have to prepare and cover the subjects in a quick manner. Okay, like you are studying hydrology, simultaneously you should study soil environment, like this, so that all the things are getting done at a rapid pace. Okay, or if you want to do it in a more rapid manner, you can join the batches also, which are there in Gatewala app. Okay, so I hope this is very, very clear to you. You can join batch in which course will be finished by the October. If you have if you haven't covered any of the topics till now, then you can join those batches also. Okay, so stay blessed, take care, we'll catch up tomorrow.